LLM models by knowing or unknowingly. It's like Gemini. If we using Google, then obviously Gemini is a part of it. And if you are doing some research, you might come across several times about the ChatGPT, which is OpenAI. And if you want to do something like code, it's a large set of code, and you have to provide a project repositories and everything, and you have to come with something visually appealing, then you will familiar with Anthropic family as well. So we'll have a walkthrough on each and everything. It's not a platform specific for now. And yeah, so this is what the session agenda. So it starts with introduction and LLM works, and it ends with the benchmarks and context video. So these are the topics that we are going to discuss today. Okay. So what is this session is about? It's not about a theoretical explanation of each and every topics. It's mostly about the functionality behind each and every terms. That's what today's plan is. And we'll discuss about the real system and the real failures, which is in the real time. We might not come up with several scenarios there where our actual system might fail, right? So that's what our today's plan is. And at the end of the session, I'll make sure that you will actually have a clarity about how the LLM works and what is RAG, when to use RAG, fine tuning, and when the prompting is more than enough. And sometimes there might be a scenario in production that actually fails the entire system, and we'll look into what actually that cause behind it. And we'll also walk through on the few topics like guardrails, PII, and injections. So these are the major thing. If you are moving on to some organization and you have to actually build something real time, then these are the topics that you that actually require major attention, I would say. Okay. So how the LLM works. Actually, LLM is trained with a huge amount of data. So it is not a specific files documents. It's actually different range of data and different range varieties, and the large amount of data has been used in order to train specific model. And before getting into LLM, these are the terms that you have to actually know in order to understand what is the functional behind it. The first, it's not the process exactly. Here is the flow. This is just for your understanding about the terms. Okay. So the token is something like a word. If we are giving some sentence to a LLM, so what the first step it will be like, it separate the words, a sentence in a word. Okay. Sorry, a word in a sentence. Like let's say I'm just using a sentence like the cat sat on a mat. So the will consider as a one token, and each and every word within a sentence will be considered as a separate token. That's what it is. Once again. Okay. So it's like isn't here we have the words like this sentence is not a actual word, but I'll just give you a quote you some example here. So the is a separate word, smallest is a separate token, unit is a separate token. Similarly, each and every word in a sentence will be considered as a separate token. So that's the one process that actually happens behind the LLM. And the next is next token prediction. So what is the next token? Let's say I have a word, I have something like the core mechanisms. Here we have the core mechanism, right? So what should be the next word? How this word will become after this word? So that concept behind is the main phenomenon that runs the LLM actually. And then we have a temperature, which actually decides what is, once again. So yeah, we have the temperature. So the temperature actually, Gemini have 0 to 1, two range of temperature, where 0 means the answer is straightforward. It is a factual based content. Whereas if the temperature is 2, or sometimes in most of the LLM which have only the temperature, maximum temperature is 1, which means it gives you more creative content. Okay. And here the one more thing is context window. Context window is like in the chat gpt also you might come across with a few chats, where might you might come across with one scenario where you have typed several prompt, and it shows like you are exceeded this context, you have to start a new conversation, which means this one single context window will carry the entire chat history, which might be stored in somewhere, which help the LLM to understand what really happens behind it. That's the help of context window. And the predicts and not knows, so which means like it is not aware of the entire data that we are trying to find, but it know what should be comes next. So I'll just explain you in detail how it actually works. But for now, the flow starts with input text. We will send some input text here. It will get tokenized as in each and every sentence, sorry, every word in a sentence will be separated, and then it gets embedded. Embedded is actually a numerical representation of a word, which means a word can be represented in several factors. Like in the three-dimensional, we have x, y, z, right? Similarly, a word can be represented in several way, like based on the color, shape, or sometimes we can refer it based on the how compactly arranged it is, something like that. So by keeping all the dimension into consideration, this will be created, and that helps to find how the word is relevant. Okay. And there comes the attention layer, which helps what comes before the word that we are trying to find and what comes next. And finally pick the next token. This is what the flow of the LLM actually. And I'll just show you a quite simple simulator about the embedding and other things, so well you get an idea about it. Hope my screen is visible. There is no delay, right? Can anyone unmute yourself and mention if there is any delay from my end?
No, we can see.
Okay, thank you. Thank you for the confirmation. So yeah, let's say here I'm using a word to vec model, which is actually a embedding model. Okay. And you could see something like points, right? Which is 10,000 points, which means we have something like a 10,000 words here. And the dimension is something, we have 200, which means it has been represented with the help of 200 factors. That's what it is actually refers here. Once again. Okay. So yeah, I'll just show you one word. So where embedding is actually like. So if I'm mentioning a word apple, so what are the possibilities that apple is going to represent? So I'm using the word just an apple, right? So the apple can either represent something relevant to the brand, or a gadget which is like Mac, that comes under the Mac, or if it may also represent the iPhone, iPad, right? Similarly, on the other side, it can also represent a fruit. So these are the two scenarios that might actually cause a confusion if you want to extract something. So I'll just type it out here, Apple. So with the help of this specific model, okay, yeah, with the help of this specific model, we are just finding out the nearest points. This is how the embedding actually works. This is how we are going to search most of the values, what going to come next. Okay. And for this, I'm just searching Apple. So we have Macintosh, Microsoft, OS, Amiga, IBM, whatever that relevant to the tech, or some gadget, or sometimes the mobile, or whatever the software providers, right? That is relevant or closely related to Apple is listed here. But it is not, nowhere it is mentioning something about orange or something, right? Orange might also comes into somewhere, comes closer to the Apple, right? But it is not listed because we have only 10,000 words. But if we are using some other model which has been trained with multiple data, which have been vectorized using the multiple data, then you will find a closer values as well. So we'll change this to some other higher one.
உள்ளம் உருகுதையா முருகா.
Yeah. So now you could see the words are too, we have enough amount of words that can find the relevancy between each and everything. Okay. So now I'm going to search the same word, apple. So you could see the words here is 71,291 words and the dimension remains the same. But now I have mentioned just an apple, the same word, but with a different embedding model. Okay. Okay, so now you could see something like Macintosh. Again, you are getting some similar words. Macintosh, Microsoft computers, which is closely associated with it. But in here, you could see something like, yeah, okay. So you could see something like, once again, a lotus, which represents the flower, because here it is apple, which might be considered as a fruit, and you could see some other thing that can be closely related to apple. So it actually differs because the number of words it has been trained on will also affect the way it is actually provides the output. So it is always you have to make some R&D before actually going on to model selection, where you have to work on specific scenario, right? So you have to do some R&D before actually finding or finalizing which model you have to use. That's what I would say. And yeah, how the LLM works. So let's say this is the word I trying to find here and this is the word. Let's say I'm just removing this. So what is the scenario happening here? As I mentioned here, the first step is input text, then it is getting tokenized, right? So this is the step here. But the tokenize won't alone won't be sufficient for to actually generate the next word. So how it is happening is like this is you can ignore this because empowers is a single word. It might be a mistake in the simulator, but how it works is it separate each and every word in a sentence. Okay, and this is called tokenization. Then we have something like a token embedding, which means we are creating a embedding. Like here we are creating an embedding. It has the closest value. Similarly, it might have some ID within it. For each and every embedding model, it has some ID. So that ID will be added. It will be appended with the positional encoding, which means data is the first one, so it comes with 0. So it's like 0 comma 6601. And visualization, which is the second letter, sorry, second word in a sentence, so it goes with the number 1. So it appends with the ID, respective ID, which is 32704. Similarly, each and every word's ID will be combined with the position, so that your LLM will understand which word needs to be come next. Because we might not decide the next word based on the two, because that's just you can just that doesn't have any meaning to it. It's like a preposition, something like that. So it doesn't carry a value to it. And you also have to finalize which word actually plays a major role to find out the next word. Okay, so for that, I'll just close this. This is the major um, mechanism that you have to understand to actually understand how the LLM works. So it's actually split it into three different thing, which is query, key, and value. So here it is going to happen in like a matrix multiplication, I would say, a dot product sometimes. So this is how it is going to be. What happens in the each head is, so the dot product will be done, and each and every time you will find out which value plays a major role. So like data have the major role, and if you could see on the next step, we are finding out the diagonal values because the diagonal are same, right? The data and data goes together, visualization and visualization goes together, so it's a major role. So we are going to ignore the diagonal part. So here you could see whatever the dark shade, right? That represents the importance of that value, that word. Okay. So here we have data in a darker shade, but you could see the shade getting lighter towards the two. Similarly, you could see some other darker shade that actually emphasize the importance of each and every word. So after the multi-head self-attention, we will get to know which word actually plays a major role. Okay, only that word will be considered for the next step. So I'll show you. Okay. So as I mentioned, the temperature, you have to understand here we have the temperature range of, okay, here it have the maximum of 10, but what I would suggest is like zero point 0.2. See, when I kept zero point 0.2, you could see the word visualize is getting more importance, which means the actual value that needs to be come next. But if I'm increasing the value to somewhat 10
சவுண்ட்
or
வருது எங்க
8,
இருக்கு
so
மீட்டு
you could
கொடுத்துருங்க
see
அது
the
அங்கே லேட் ஆகுது.
create is getting importance. Now it is 10. So see, so there is no meaningful sentence can be formed by like data visualization empowers user to see what is actually see mention refers here. That is not a complete form, right? It is just adding some creative content. So if you are writing some stories or
பார்க்காத
some
பார்க்காத
a sci-fi story, or sometimes you are just
சரிகம
writing a
இது
poem or
எஸ்ஆர் வெயிட்
something, then you can increase the temperature because it will enhance the
பண்ணுங்க.
creative
பொறுமையா இங்கே பாருங்க.
words
இதையும் ஹைட்
in
பண்ண
each and
முடியும்.
every phrases. But if you want to keep
சவுண்ட்
it
ஹைட்
more
பண்ணிடுறேன்.
factual, then you have to reduce the
சரி
temperature.
சரி.
So now we are having the visualize, and top k, what does it actually do
எப்படி
is
ஆக முடியும்?
it will consider the top,
நான் அதை
what
கிளிக்
if I'm
பண்ணிட்டேன், வேற
mentioning
ஏதோ
5,
வந்துச்சு மேலே.
it will consider only the top 5 values. As you could see here, 1 2 3 4 5 6, but here it will consider only the top 5 values. Okay, and I'll just increase
ஆமா
it to 12. So it keeps
சரின்ட்டா.
on increasing, right? And I'm just
நான்
reducing
அதில்
it to
இருக்கிறேன்ட்டு.
1. So now only this value is getting finalized. That's how it is. So based on the temperature, the next word will be listed, and this word is coming from the embedding model, the same embedding model that we are trying
நான்
to
கிளம்புறேன், நினச்சேன்
embed
நான்
the
இருப்பேன்.
query, right? Similar, the same model is going to be used to actually find the next word as well. You
சார்
shouldn't
நல்லா இருக்குல்ல.
use any different model because that affects the actual context of it. So that's what the process is. We'll move back to this presentation. Okay. And for this prompt engineering, for actually getting the answers, there are several techniques to incorporate to get the answer. So one is prompt engineering technique. So within that we have zero shot prompting, few shot, and chain of thought. And it is not it is not limited to these three. There are few others, which is meta prompting, and you have something like role based one. So you have to be understand when to use
அதிலே ஒர்க்
which
பண்ணிடுவாங்க போல.
prompt, because this will also consume a lot of
ஸ்பெசிஃபிக்.
tokens, which will actually increase the cost that involved in your app development. So we have to be make sure which prompt
எங்கே
should be
போயிட்டு
used for the specific scenario. So I'm just asking this question here. So the classify the text into neutral, negative,
ஃபுட்பால்
or
விளையாடுறியா?
positive. And I think the vacation is okay. I'm just giving this as a input, and what the model needs to
கடையில்
do
ஓடி
is it
போயிட்டாரோ?
needs to give me whether it is neutral or a negative review or positive review. That's it. Okay, so I'll just send this. Okay, it is giving me the neutral because it is straightforward. This is what called zero shot prompting, which means we are not giving any example here. We're just stating some questions, and we directly asking the model to check whether it is neutral or negative, what is the sentiment available there. That's what the
என்ன
our
பயப்படுற
target is.
மாம்பழம் சொன்னோன்னே
Now I'll just give
பிடிக்காதாண்ணா?
something like few short prompting.
பிடிக்குமான்னு?
Okay, so
இது
here you
எப்போ
could
வந்தது?
see I just changed few things. Like, I'm not giving what needs to be done. Instead, I'm just
நானும் வேலை
stating few
பார்க்குறேன். எனக்கு
example.
ப்ரொஃபைல்
Like,
சிஎஸ்
this
ப்ரொஃபைல்
is
இருக்கா?
awesome, which means it is
ஆமா.
negative.
ம்.
Okay, this is bad,
தி
which means positive. You could see this is not a real
நான் நான்
time
நான்
sentiment, because this is
அப்படின்னு
bad
ஒரு
as a negative,
பிஜிஎம்
but
வேற
I'm just
போட்டுருமா?
making it, um, since it comes
யார்
with an
டேரக்டர்?
exclamatory, I'm just confusing, or I need some it in a specific format. So I just giving that
எப்போ டேரக்டர்?
this is awesome as negative, this is bad as positive. Wow, that movie was rad is positive, and what a horrible show. So in the similar way, it needs to show what is the sentiment here. Okay, I'll just give this.
ராமாயணம் எப்போ வருது? இன்னைக்கு இது வந்துருந்துச்சு.
Okay,
இன்னைக்கு இது வந்துருந்துச்சு. டீசரா?
so this is how it is generating. So
ராமாயணம் போல.
which means you don't want to instruct your model much more onto how the output need to be generated. Instead, you just state few example and it will give you as much efficient answer that you would like to get from it. Okay, that's how the
பெருசா இருக்கு.
fusion prompting will help on it. Whereas in this, there is one more prompting which is chain of thought, where you will get a step by step. Let's say we have the guide, right? In school days we will use some guide to actually solve some mathematical problems, or to actually write the conclusion or a solution for physics statement, something like that.
சிஸ்டம் மட்டும் நடக்குது.
So it will give a step
சிஸ்டம்
by
அந்த மாதிரி.
step iteration that has been happened. So that is what actually called as chain of thought. Yeah, chain of thought. So these are the three different types of prompting. And if you want to work this in your local environment, you have to click onto the view code. So this have a different code options. You can choose whatever that
எல்லாம்
you are
போட்டீங்களா?
comfortable with. So here we have the Python. So I'm just choosing the Python since it is a Cohere. I'm just using sorry, this is actually installing the Cohere libraries. Then you have to define the client, and this is how you actually need to explain what needs to be done in the messages. It's like role. There are several roles like system, assistant, user, and yeah, these are the three major role. The system is actually we haven't done anything here, which means we are giving some instruction to the system. That is actually the role or characterization for the system. And then the user will user, which means us, we are going to ask some question to the model, and it is going to generate few contents based on that. That's what the flow is. So this is the thinking. So yeah, I'll just explain you few things on the right column. You have the parameters here. So here there are several models. You can select anything from here. And function, which means if you want to call some specific function, like a new tool has to be defined. These are the format has been defined. You can edit here itself and upload it. That is more than enough. And here, if you want the output in a JSON mode, okay, you can directly enable this and add a schema. Okay, I'll just go with this schema. I have few things here. So yeah, if it is about the bio, the description is like the name of the person, number, age of the person. So here are some of the schema. You can also come up with the new schema. You can add your own schema here. It's like something like response, and for the response it needs to be negative or positive, something like that. And thinking budget, this will affect your this will increase your cost if you are not considering this, because if you are giving 2000 tokens for thinking, it will
Salary
take so much
salary.
time to actually understand what is happening, and it will consume most of the time. So if I'm asking a question, I don't like to wait for 5 minutes to get my answer, right? In that case, if it is a simpler case, you can reduce it to 200, or sometimes 20 is more than enough to actually for the thinking budget. But I would suggest go with something like 200, so you will have at least 3 to 4 lines of um, context to actually come to the conclusion. And these are the advanced parameters, which is temperature, You could see one, right? But I'll show you one more thing. Okay, I didn't open that. In Google AI Studio, you could see the temperature maximum as 2. Okay. Similarly, see, these are the parameters that actually makes your output sometimes more effective, sometimes more complicated. It based on your scenario, you have to take up the decision. And how to do that is actually what we are trying to learn today. Okay, so this is the right way to do a prompt engineering. So you can't just go and write a prompt because that will use a lot of tokens and it will waste the time and it won't be still effective. You have to go and ask, rephrase the sentence. No, 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 this is not what I expected. I need something better. Okay, instead, what you have to do is you have to go in this way. Like what usually we will do in a chat GPT or Gemini is help me with this. We go with the direct answer, sorry, direct question, which might be confused statement for the model. Okay, and negative framing, which means like don't give a lot of negative words to the LLM because it will get confused in the longer context. So if you are going to work on some organization and you are going to push your code to the production, and if you're having the prompt which is having the negative statement more, then it will there is a high chance of failing. Okay, you have to specify the output format because sometimes you might require only 3 lines or just a single line of output, but it might sometimes produce 10 lines or 100 lines of output because we are not explicit, we are not mentioning that specifically in your prompt, right? So we have to make sure that we are doing that. Similarly, we have one more thing. So how to actually give the right prompt is we have to define the role, which means like the first characterization for our model is the first step. Second is context. So you have to give the context, like what needs to be done, and then task should be like a chain of thought, which means like step by step. You have to define what are the task, what is the first task you have to do, what is the final task you have to go with, and the format. The output may be in a JSON format or a string, like just a paragraph or something, or sometimes it is bulletin points. Whatever the markdown formats that you would like to get from in your output, you have to specify that. And the constraints, you have to specify what are the scenarios that you have to consider. So here they are not using don't, instead they are using never, because the negative shouldn't be directly negative, which is you can't use the word like not, don't do this, because that is like sometimes it might consider as a way that it can perform. Okay, so that's what the point that you have to keep in mind in while you're writing the prompt. Is that clear so far? I'll give some pass here. So if there is any points that needs to be discussed, you can unmute yourself. We'll have a discussion and then move on to the further topics. So we'll have a few discussion about the dragon in the next half. But first, I want to make sure whether this topic is clear or not. If there is anything that need a discussion or slight explanation on that, we'll go on that and then move on to the further topics.
No, ma'am, we can move to the next one.
Okay.
We are clear.
Okay. Okay. Thank you. Okay. So yeah, this is what about the prompt. Yeah. Okay. So yeah. So this is what I would like to actually explain about the prompt engineering. So you have to make sure in the production that you are following this set of rule, which we usually call this like RCTFC, which is role, context, task, format, and constraint. These are the major components of each and every prompt that we usually use in our production. So if we are directly using this, there is a high chance of failing most of the time. So it is always better to go with some prompt that is more effective rather than rewriting each and every time. Okay. I'll just move on to the next slide. This is the interesting topic, I would say. It is not like highly, yeah, it is kind of interesting topic because in production, so there might be several time you have to actually retrieve few information, or sometimes you have to call several API calls for one single function that might be repetitive. Let's say I have some uh, things that needs to be fetched that is actually completely relevant to policy, I would say. Okay, I'm sorry. So I have something relevant to the policy here, but each and every time a user comes and ask about some questions about the policy, it goes to the database. Okay, something the database or informations, and after going to the database, what it will do is it actually pass this to the LLM. The LLM then formulates something, the information, and finally generate an output. Okay, the output will be generated, but it will take a entire process, like you have to wait for this entire process to be completed, and it won't be the better approach all the time, right? What if some questions is actually repetitive, like I'm just going to the agent, sorry, sometimes I'm going to the LLM application and I'm asking something like what is the plan live, or what is the procedure that needs to be taken in order to move on to some other country while I'm in a, like while I'm actually in a project in Accenture or so and so. So in that case, many will come up with the same question each and every time. If we are following the process which is calling the LLM and finding out in the database and providing the output, it will be hectic and it will also incur much of the cost. But what you can do is, for the repetitive question, if the one question has been asked multiple times, you can store it in a as a cache. Okay, which is like a buffered memory, something like that. You can store that in a cache, and from there you can directly access it, which means, so first input. Okay, input will be started, and once the input is done, you have to classify whether it comes under the cache. If it is yes, then you can directly produce the output. If it is not, then you have to call the LLM and follow the same step. That is the major thing that reduce most of the cost that actually incurred on the LLM calls. So what is like, if you have, it is like we are storing the repetitive task as a prefix, so we will just directly go there without calling any LLM. So there is no cost in it, just a few information that directly fetched from the cache, prompt caching, that's it. So where it will be useful, so it will be useful in the large system. It is not suggested for the smaller one, because for the smaller you can directly fetch that within a milliseconds, so it won't cause any issue over there. But in the large system, you will have a multiple files in the multiple folders or namespaces, or sometimes multiple buckets. It depends upon the platform that you are using. But each and every time if you are going on the retrieval process, it will actually spoil your entire process. So it is better to keep something like prompt caching whenever that you find there is a repetitive task that might
Madam,
be.
your
Yeah,
screen not visible, madam.
is that so?
visible
Once
for
again.
us, ma'am.
Okay.
These are the
Okay, I'll just anyhow I'll do. Maybe could you please check your internet and rejoin? Will that be possible? Or else I'll also try to reshare again. Hope it is visible now.
Yes, ma'am.
Okay, thank you. So yeah, this is how it is. So for the large documents, you can go with the prompt caching, or sometimes if it is a repetitive knowledge-based questions, you don't have to actually call the RAG pipeline. And for the high volume apps, if it is bulked with data, then you can actually go with the prompt caching. When it is not suggested, so it's actually if your prompt is too short and calling that is a straightforward, then don't go with the prompt caching. And frequently the context might changing, then it is not suggested to use the caching, because that will bloat the memory where you actually trying to store your few of the things, and that will also cause higher latency. So because our motto is to reduce the latency, right, it is not a right approach. If your prompt is less, and if your context, or sometimes if it is not a repetitive task, it might change often, then don't go with the prompt caching. And if it is also low volume and one of calls, which is like one call to the output, then don't go with the prompt caching. So at the end of the prompt caching, what will happen is, this is what. So I just show you few datas like here. So model, I just listed few models: llama 2, 3, gamma, and the 5 3. Okay. So for the non-cached inference, you could see that the seconds here, right? Here it is 143.98 seconds actually, as um, has been consumed to actually generate the output, whereas in the cached for the same process, it just taken only 65.84 seconds. Similarly, each and every um, process on every model, you could see the drastic change, right? It's like double the time. So if you are using the cache, it will reduce lot of it, it will save a lot of time. That's what I'd like to mention here. So it is always better to use the prompt caching when there is a repetitive task or longer documents, or sometimes you don't want to um, go to the LLM calls many times, something like that. That's what um, the main purpose of this prompt caching is. Next is the main approach, that is actually building a real LLM application. So in this, it is not a complicated thing to actually create an LLM application. You can go with the no code platform, or you can go with the coded one also. And as you could see, I have shown you one of the Cohere environment, right, where you can directly download the code from the top right corner. So that is actually one step to deploy your code. So that's how simple it is. But how it works, it starts with the input. So the user will send an input. We have an prompt, right? Either it is zero shot or one shot prompting, or some few shot prompting. Okay. Whatever the type of prompting we are using, that will also be there. Once it is done, along with the the input and the prompt gets added, and it will be sent to the API call. So here the API call is like the call to the LLM. So that's what, yeah, the call to the LLM will happen. And once it is done, the output will be generated. It's like the parse response, which means the LLM raw output. But what is the output here is, it is not the same as the parse response. The response is the direct output comes from the LLM, whereas the actual output we require is the constraints incorporated output, right? So this is the finalized output. The prompt might have some constraints, so that needs to be added to the output, and then it needs to be formulated in such cases. So that's how the flow is going to be. And where in production, there might be scenario that it actually fails. So let's say I have created several agents, and one time the agent has been working fantastically, and it is as 99 percentage um, closer to what we have actually expected for. But while we pushed onto the production, it doesn't respond in such a way that it actually does in the previous time. And what actually caused behind is the Amazon, yeah, the Anthropic model, which is Sonnet. They have updated the model, which means it has some few more trained data, so it will perform in a different way. So it's not a mistake from your end, but slight changes in the model, which is like preview model or some other model, will also cause a drastic change in your output. So it is always better to go and check and on each and every functionality of your LLM apps that you have developed. So there should be it's like we have some life cycle, right? So SDLC, for that you will go with some agile methodology and will check more often. But for the LLM, there is no specific timeline. You have to go and check your LLM application more often than the usual software that we develop. Okay. So there might be some unexpected refusals because the production context, it might differ. We might go with the normal um, phrases of the prompts, but in production we there might be a drastically different or something unexpected data might also be asked, right? So there it might fail. Response length inconsistency, this is because in the prompt we have to follow RCTFC steps, right? Where in constraints you have to clearly mention what is the format of output. Should it be precise or a lengthy one, or should it comes in the JSON format or in a bulletin? So that you have to clearly mention in the constraints. And then in engineering, so the timeout, the latency issue, the prompt versioning. So the prompt versioning is like you keep on adding some information, but that might not be added to your agent or application. Then there comes the issue. No regression test. So these are the cases where it might fail. And the cost and latency, yeah, uncached large prompt on every call will also cause the latency. That's why we just learned about something like prompt caching, right? And no streaming. No streaming is like streaming is one of the best option. Like if you could um, no user will wait till the LLM actually generate. If it is take 10 minutes, some output actually needs to be shown to the user at the right, it's like real time, right? So for that, streaming is needed. And wrong model size for the task. So let's say your task is so simple and you are using a higher model, which is larger model, then it will take too much of time, and the customer won't be, or whoever the user won't be satisfied with that. So that's why it is better to analyze what are the factors that is involved and what is the actual need, and then come up with the final approach. Okay. And for the RAG, we have these steps. RAG is actually retrieval augmented generation, which means we have LLM which have a knowledge on it, but sometimes we need to add some domain specific information. For the domain specific information, sometimes specific to um, specific organization or medical relevant information needs to be added to the model. Then you have to go with the RAG, which actually retrieve. First chunking is the first process, and then embedding creations will be the second process. Augment to the prompt, whatever the query that we asked, right, as the first step, that will be added here, and finally the output will be generated. And for this, there are several approach, which is fixed size, sentence level, semantic, skip chunking, and there are few more other. This is just a higher level of what actually RAG looks like. So for that, I'll do share this step. Okay, I'll just go with first with this simulator. So where top three, okay, I'll just define this, which is like a top three means top K is actually I'm keeping it for two, which means whatever the top three files or two files that comes closer to the query that I have asked will be considered as the answer. That's it. Now I'm keeping this as a question, which is capital of Australia. That is going to be my question. Okay. And how the step will be is like user will ask some query, embedding will be created for that query, and vector search will be done. After the top k retrieval, the re-ranker, which means rearrange whatever more closer to it, and then prompt construction, which means the query, the prompt along with the fetch details will be combined and passed to the LLM for the generation. So you can visualize this here. I'll just pass on each and every step. So this is our user query, which is like, what is the capital of Australia? We have few files here. So yeah, what is the capital of Australia is the first step. Now the text will be getting embedded using some embedding model. You can use any model. So here they are using OpenAI text embedding model. Okay, so this is the model that has been used to generate this embedding. So we have created the embedding. The next step would be vector search. Okay, vector search, you could see that we have a query here, and these are the files that we are having in the vector db, which is vector database. So whatever the files that we are uploaded, right, that will be available here, and our questions which has been embedded will placed here. So what is the closest file? So these are the closest, right? So we have something like a range, which means within this range, if I kept three, the three files, the closest three files will be considered. That's how the process is. You will see that now. Okay. So yeah, since I kept the K as 3, which means it going to retrieve the chunks which is similar, and it only finalize with 3 chunks, which is Canberra is the capital of capital city of Australia. Similarly, there are few other details that is relevant to this specific capital of Australia question. And you could see the similarity score 0.999 and 0.998 and 997. So in such order it is getting re-ranked. So sorry, it is just retried, now it will get re-ranked. Okay, yeah. So you could see this is moved on to the first because this is mentioned direct answer, which is capital. Here the population, and the third is actually where it is located. That is actually additional information. So we are keeping it in the third place. So these are getting re-ranked. Okay. Now the step is prompt construction. What is prompt construction? We have initial set of instruction, right? So you are a helpful assistant, answer using only the provided information. That's what our system prompt is. And the context is retrieve inserted three chunks. Based on the retrieved chunks, you have to produce the output. Here we have the tokens, the context window, everything. So the query, you could see, you have seen that, right? Which is like the capital of Australia is our query. Now the LLM generation will happen. That's it. This is how the output is actually generated. And for the RAG, as I mentioned, there are several steps to actually implement the RAG, right? I'll just show you how each step plays a major role. So the text splitting. For the text splitting, we have, which is actually a chunking. Okay, this is what mentioned here as a text splitting. So what is chunking is actually it is going to divide the documents. You can't send the entire document to the LLM because that will also take lot of time, lot of amount, and lot of it will actually ends up in hallucination. So what you have to do is you can go with any of the split strategy, chunking strategy. That's what the actual name is. So I'll just go with the fixed character. You could see the fixed character. I kept the chunk size as 200 and the separators as the double quotes or something like that. Overlap size. Overlap is like to remind the context, like it needs some connection between these two words, right? For that, we are keeping the overlap size. And fixed character means, so this is the input, source document, okay? And you could see exactly 200 words will be there for each and every chunk. So this is first chunk, this is second chunk, third chunk. So you have several chunk, okay, based on the size I have mentioned. Let's say I'm just changing it to 500. Okay, Now you could see the size is getting varied, right? This is how. So the chunk now it is 17 chunk. Okay, if I'm keeping it for 20 200, now the chunk is 18. So if you based on your requirement, you have to come up with the chunk size. So it will actually affect your output also. So you have to be make sure that you have to come up with the right chunking strategy with the right amount of size. Now we'll go with the recursive character. Recursive character is having some connection with each and everything, like of parameters to generate original output for, and then the other words getting overlapped through it, which is like similar to the overlap, but each and everything will have a connection onto the next or the previous one. That's how it is. And we have the parent child. This is one of the good kind of a good approach if you are actually creating some um, larger knowledge base which needs to connect with the graph based. Okay, there you can use this actually. So one parent will have several children which is based on the specific topic that it is actually. So you could see what is retrieval augmented generation. Why is because each and every questions will be considered as a separate, or each and every topic will consider as a separate parent. Within that parent will have a different points, will be a different children's. That's how it is. So it will reduce your time. So let's say I have different chunk, you have to go to all the chunk, right? But here you can find out the parent and then find within the parent which children, which child a chunk is actually representing the specific information. That's how it is. Now the second step is vector embedding. As you could see here is embedding, right? So that's what here we are trying to do. So child of parent two. So you could see the embeddings for each and every chunks. So the chunk one, these are the embedding. Similarly, we find the embedding for each and every chunk. This is how the RAG works. We upload the document, we chunked, which means splitting into a smaller files. After it is getting chunked, it will be created as an embedding for each and every chunk. That's how the next process is. Finally, we move to semantic search, which means I'm just asking a question, what is tag, right? I'll just ask, what is, okay, why rag is used, okay? See, there is a change in the question. So here I asked why rag is used. So it find the closest value, which is chunk number 31, 4, 16, 62, and 64. I'll just zoom it. So these are the files that is closer to this question. But if I'm just moving on to the different question, rag, explain. That's it. Now the file that explain the rag is available within here, which is chunk 28, 25, and few other chunks is actually explain the rag. Similarly, that's how we are going to find the information. Okay, and you could see the chunk also, which is closely available with similarity score is high, also listed in a specific order. Once that is done, the next step is content generation. Okay, now we'll see what is the impact of the temperature. Okay, I'm just asking one question, which is like what does drag stands for here, but you can ask any questions. Okay, um, and once again, okay, this is the system message, you can come up with anything. So I'll just reduce this to 0. We'll see how it is actually generating. Retrieval augmented generation is a process that optimizes. It is just giving you a straightforward answer, but I want something creative sometimes. Okay, okay, maximum value is 1. Now I'll generate the same content. Optimizes the output LLM by referencing some values has been hidden there. I don't know, there's some issue here, but what it is trying to give you is detailed connection between things, which means like enhancement of the straightforward answer. So that's what the RAG actually, this is how it works. Okay, and finally we'll move on to the slide. Yeah, you could see, right, the OpenAI model. We have used something like OpenAI model. Similarly, there are several other models. This is the model that we have used in this scenario, so which is text embedding. Similarly, you can choose the model based on several scenario, like by task, whether it is general task or domain specific task. Some model will be good for medical oriented, some will be good at technical, or sometimes it uses several jargons for specific industry. So you can select that specific model. And if you are using the language, you have to make sure that whether this model is good with specific language. Even in, let's say, we have faced one of the European clients once. So there within the Europe, like what is it, closer to the Dutch, there are several other languages within some one small region itself. There are several languages has been there. But if you are going with the translation, or if you are creating some application that requires the translation, you have to make sure whether that model is capable of um, actually translating this specific language. That is actually sometimes it will be a drawback. So you have to make sure whether it is suitable for that specific language. Then dimension and cost. So you have to find out if it is a higher dimension. See, we have seen one of the model, right, that have 200 dimension, one has 100 dimension. If it is higher dimension, then it is obviously higher cost also. So you have to make sure whether it is good to go with that risk, or it is better to keep that simple as possible. That decision has to be made after checking whether it is the right approach or not. So the retrieval quality might affect when the chunk is large, sometimes small, sometimes wrong model, and these are the factors that might affect the systems. And before choosing the database for storing the vector information, you have to consider these parameters. Like, are you going with semantic search, which is actually meaning based search? Then you have to choose the vector DB. It is a structured data, like a table, column, row, column based approach. Then go with relational database. If you are going to come with something like a node edges, not a node and edges, some branches within it, and a a relation between each and every entities, then you have to go with the graph DB. And query type, if you want to find a similar word, then go with this. If you want to find the exact match, then these are the parameters that you have to consider. So I hope this is easy, quite straightforward. So I'll just skip this for now. And yeah, so when to use the fine tuning, when to use the prompting, when to use the rack. So if you are using something like domain specific, LLM has some idea about it, but it is not specialized in specific domain. Then you have to go with the rack. And let's say your model is working fine, it is having a knowledge about whatever that you are asking for, but it is actually not providing the output in a professional tone. Or let's say I'm developing some agent for my some hospitals. There it shouldn't be professional, it should be patient friendly, it should be like a polite tone. It shouldn't explain the jargon, and it shouldn't go with some fancy terms and all, right? It should be straightforward. There I have to use the fine tuning. And if it is a prompting, it's like just a few set of instruction, that's it. This is where you exactly use these three things, but it is not mandatory to use all the three. So you have to understand when to use it, why to use it. For the hallucination, this is actually a major issue behind the production many times, because hallucination means like the output will be looks like exact answer, but it is a wrong answer. Which means the rag, we are uploading some files, right? It might be outdated, or we kept the temperature low, so it will give the factual. Sorry, it needs to be low, but it sometimes get increased, so it gives you creative content. So make sure that you are keeping the temperature less, grounding with the rag with updated information, not keep the top k files as less as possible, so that it will give more relevant information. And always evaluate the answers that comes out of it. Yeah, this is the drawbacks that can be done. There is one scenario, I have worked once for Gemini. We are using the Gemini, right? initially there is some issue with the Gemini, and you could see whoever following up the news might know that at the start of Gemini and ChatGPT performs well, whereas Gemini doesn't. And we have been a part of a red teaming where we resolved several issues. The major issue is prompt injection, which means like I just use some several prompt like how to attack someone or how to actually be violent on something. It is actually helping me out, and sometimes it also give me a narrative that it is not supposed to do. So also it is getting stand on several things, but now it is has been resolved. So that has been evolved based on few steps how to actually get rid of that in your app is sorry, whatever the LLM application that you are doing is. One is human evaluation. You have to include the human in the loop every time, and there are several automated metrics like blue rogue for the structured task. And one more thing is there, which is actually ragas. I'm sorry, I couldn't write it here. So it is ragas, ragas, which is actually helps you to find whether this is the content retrieved from our knowledge base to evaluate your RAG pipeline. And LLM as a judge, which means keep your another LLM as a judge and proceed with that process. That will actually reduce most of this issue. And next come the guardrails. This is for your safety purpose and privacy. After doing all of this prompt, all of this data restriction and everything, still there will be several issue arised. So which is like prompt injection, as we discussed earlier. Someone, I can ask some questions, LLM supposed not to say that answer, but it will again comes with the answer. So these scenario needs to be avoided, and for that you have to follow this step. It's just like you have to give an input. So we are just passing an input. Before passing on to the LLM, there is something that you have to keep as input guardrails. Guardrails is like a kind of um, again some kind of app or some, you can consider as a different LLM with some prompt definition and everything, keeping temperature less, which has been trained LLM, something like that. Okay, that guardrails will actually check whether your input is a valid input, whether it have something that will affect the database or that will affect the output, or it is not a right way to ask the question or something. It will stop right here itself. It won't actually pass down to the LLM. Similarly, the LLM might also generate some information that is not supposed to expose to the your customers or your user, right? So there you can keep another guardrails which is at the output layer. So this is how it is. And where it will be useful, right? Sometimes I might directly copy paste my entire code that have the secret password, credentials, everything, which is used in the enterprise level. Okay, and I'm just entered it. I don't want my LLM to actually extract that and keep it for some other purpose, right? So the input guardrails, what it will do is it will block there itself, or sometimes it will anonymize the information. It will replace the names into some usual notations that like stars or dots or something. It gets anonymized and then the input will be shared. If it can't be changed, then it will actually restrict the user to send the input. Where it will be useful is in the medical, or medical, you don't want to expose the user informations to the agent, and some other sensitive data, uh, the clients or the user won't actually ready to share it to the LLM, right? So in these scenarios you have to actually incorporate the guardrails. And these are the common things that you have to consider, like where check for the bias, whether it has the bias or not. Transparency, there should be a transparency, and sometimes it needs to be keep the sensitive information safe also. So you have to ensure whether it is in the right approach or not, whether it is giving the sensitive information or not. And misuse patterns and the responsibility, these are the things that you have to consider all the time whenever that you hear about the word AI, because that's actually a drawback in it. And final bonus points is like MCP. So This is just like, see, this is not, you have to actually understand right now, but this is the market moves towards currently. Entire organization is moving towards the agentic AI, where agents will take action autonomously. You don't have to do anything. Agent will sit top of your prompt and do all the task by connecting to the team's outlook, or sometimes bill payment, and everything will be done within a minute or so. But for doing that, you have to have some protocols, which is model context protocol, which help. It's like a plugin. You have to like, what to say, you have an agent, you have the MCP as a plugin, and connect the plugin to every tools. So what agent will do is ask the MCP which tool needs to be called. MCP will fetch some tool and give it to the agent, and that's how the process will be. So this is how the flow is currently. And for the benchmarking also, these are the criterias or metrics that you have to evaluate. Like, y- after completing every process, what you have to do is you have to check whether it is performing in the right way or not. For that, there are several benchmarks available. For in AWS or in Azure, all the platform have their own metrics to be calculated, and these are the other ways to do it. That's it. And for the context window, we have discussed earlier, right? You can keep it as a summarizer, sliding window. Sliding window is like, for the two turns it will keep the information, and after that it will delete it, so the storage won't be heavier. So these are the steps, I would say. And yeah, I'll stop right here. What we will do is, we'll have some discussion for another 5 minutes or something. If you have any doubts, or if anything needs to be discussed, you can unmute yourself. We'll go one by one.
Good evening, ma'am.
Yeah, good evening.
Uh, this is Padmanabhan, ma'am.
Yeah, hi.
Okay. Actually, what are the current research opportunities in LLM evaluation and retrieval systems and responsible AI, ma'am?
Okay, opportunity. Okay, you're asking about the opportunity, which means job, or is there any possibility to evaluate the LLM? Or
Yes, ma'am.
okay, so yeah, for LLM evaluation, there are several steps. In let's say I just go platform wise also. In AWS, once you develop the once you deployed a agent or something, there is an option called LLM evaluation. You can define several metrics, like whether it is in within the context, with RAG is good or not, whether it have safety measures. Safety measures like bias, or where any word is abusive or something. These are also getting monitored, and separately you can evaluate, and then you can come up with the conclusion. The other way to do is, you can keep another LLM with a lesser temperature with quite strict instruction, and from that you can evaluate whether the output is correct or not, then proceed with the step. That is the two ways we can do it. One is LLM as a judge, other is using the already available metrics, that is either in the portal or some in libraries, I would say.
Thank you, ma'am.
Yeah, thank you. Is there any other questions, or any other? It shouldn't be like a exact question or something. If you have any doubts, or even some topics needs to be have a slight discussion, then you can unmute yourself. We'll have some discussion on that as well.
Good evening, ma'am.
Yeah. Good evening.
Actually, I have a plan to learn LLM.
Okay.
From where I can start? Can you share? Can you give me some website to learn about the fundamentals about the LLM?
Okay. Okay. So actually, what I would suggest is, to start with the LLM, because it's not ends at the LLM itself. It is going to agentic AI, and few more thing is also coming up, right? So what you can do is you can go with some learn deep learning. That website offers few courses, many courses which is are free of cost. You can go to the deep learning website, enroll yourself, and go to few courses that you can understand a few basic concepts. Once it is clear, try developing some of the LLM in your local environment by using free key. Like you have Google AI Studio where you can get the API key. Similarly, you have Cohere. I have showed you for the RAG, right? There are several models that is available for the free of cost for sometimes. Like 5 minutes, you can have 200 calls or something, right? So try developing few LLM apps, then try moving on to the agentic level. So that's where the current market is up to. So it will be better if you start with the basic, move on to the LLM, then agentic. Then it will be better for the current situation, I would say.
Thank you.
Yeah. Is there any other questions or any other topics needs a slide discussion? You can unmute yourself. Okay. So if you don't want to unmute yourself, you can drop the question or any other topics that needs discussion in the chat window as well. We'll have that, because you don't miss out any of the question that comes in your mind just because you can't unmute yourself. Okay, you can ask that question in the messages as well. So if you have any questions that needs slide discussion, just unmute yourself, or you can put that in the chat window as well. We'll have that slide discussion on it, and then we can close the session. Okay.
Hello, ma'am.
Yeah. Hi.
Hi, ma'am. This is Priya from Chennai, ma'am, Tech University.
Hi, ma'am. Good evening.
Good evening, ma'am. Ma'am, how can faculty members introduce RAG and LLM deployment concepts through practical laboratory exercise, ma'am?
Okay, okay. So RAG, yeah, for now it requires some cost. It actually incurs some cost in it. But what you can do is you can demonstrate, if it is for just demonstration purpose. There is like a flow wise and few other drag and drop method where you can show and explain the RAG. But if needs to be understand, it is better to go with some subscription on AWS or something. Or if you can't actually rely on any of the things, you can start with
Hello,
your.
madam.
Yeah. Hi. One second, I'll just complete this answer.
Hello.
Yeah. Am I audible?
I'm audible, ma'am.
Okay. One second. Okay, so what I'm trying to mention is like either you can start developing it in a local, like LangChain is available, LandGraph is also available. You can use any of these framework, stands are there, so you can use any of this framework and connect with some vector DB like Pinecone, Chromas. There are several other vector DB that is available. You can upload the files there in the local environment and give an idea about it. Once it is clear, if you are ready and you have, if you want to improvise more onto the platform specific, then you can go with the subscription as well. Is that answer your questions? If not, we'll have a discussion as well.
Hello, madam.
Yeah, hi, sir. You're audible. You can ask your question. If there is any network issue or something that you couldn't ask your question on by unmuting yourself, you can drop that in chat as well. I'm ready to answer your question. So you can drop your question whenever, whatever that requires some discussion. Okay, if someone in the beginner level needs to build a production ready LLM application, so that's what you have to familiar with uh, basic frameworks, like whatever the framework that supports LLM call, tool connection, or sometimes some frameworks that actually helps you validates, like um, as I suggested, ragas, which is helps you to evaluate the rag based environment. And if you want to evaluate few other things, make sure that you are exploring the framework that supports these LLM and tool call. Once it is done, then you can move on to some other exploration of guardrails, which is actually mandatory in the production standard. Guardrails are the main things, like you have to find how to access the content, how to remove the sensitive data, how to actually come up with the flow that give you the consistent output. So sometimes the LLM actually provides the output that is clear, but it's not consistent over the time. So you have to evaluate on the several factors, metrics, whether it is in within the context or not, or it is comes with a biased content or it is not. That's how you have to evaluate. Once it is ready, then you can move to production. Production in the sense, there are several approach. Platform specific is like in AWS you have agent core, where you can deploy the agent that scale automatically. And if you are good with the deployment and everything, you can go with some other approach as well. Like in Azure we have a deploy for LLM deployment, you have Azure AI Foundry also. So you can go with any of the things that is most comfortable for you as well.
Thank you, ma'am.
Yeah. If there is no other question, then I think we can close this session. Um,
Ma'am, I'm audible, ma'am?
yes, sir, you are.
Okay, ma'am. Shall we wind up the session?
Yes, we can. I'm good actually here.
Okay, please, ma'am. Wait for once again. Good evening to all. Now I invite Mr. M. Jai Ganesh, Assistant Professor on Department of AIS, to deliver vote of thanks.
Thank you, sir. Yeah, very good evening to everyone. It's my pleasant privilege to propose the vote of thanks for today's day 6 session of 6-day FDP, virtual FDP program on mastering generative AI through the practice hands-on promote engineering and LLM application development. First and foremost, I express our sincere and heartfelt gratitude to our eminent resource person, Pradheena Govindarajan, software engineer, Accenture, Bangaluru, for delivering an insightful and informative and highly engaging technical session. Ma'am, your practical approach, industrial perspectives, and valuable expertise have provided us with deeper understanding of LLM pattern. The knowledge and experience you shared today have been truly inspired and will certainly benefit all the participants in their academic, research, and professional endeavor. Thank you, ma'am.
Thank you. Thank you so much.
On behalf of the organizing committee, I extend our heartfelt gratitude to our respected chairman, principal, and vice principal for their constant encouragement and unwavering support in organizing this program. I express my sincere thanks to our respect HOD, our Dr. R. Perumal Rajasa, for his continuous motivation and valuable guidance, which have been instrumental in the successful conduct of his faculty development program. I would also like to extend my heartfelt appreciation to all the participants from various education institutions for your enthusiastic participations, active interaction, and keen interest throughout the today's session. Your commitment to continuous learning and professional development has made this program more meaningful and successful. We hope this faculty development program have been useful and enriching for all the participants, and the knowledge and skill gained will effectively applied in your teaching, research, and professional endeavors. I would also like to place an on record my sincere appreciation to our esteemed faculty members and the technical team for the invaluable support behind the scenes. Their dedication, effort, and meticulous coordinations, efficient techniques, assistance, and unwavering commitment ensure the smooth and successful conduct of today's online section. I once again thank you all. Thank you.
Thank you, ma'am. Thank,
Yeah. Thank you. Thanks, everyone.
okay, thank you.
Thank you so much.